So now, I made this circuit with 5 volts, but now I'm going to be making it with 12 volts. There's some other modifications. That's 12 volts at the supply. So I can adjust how much current is going through that red LED up to about 10 milliamps of current. That's because we have this wired as a current source. We got 12 volts. This is a 1000 ohm resistor. For every volt I put across it, it's going to let 1 milliamp of current flow. That current comes through the LED and the transistor right there. So we set the current though with this trim pot, the voltage that goes across the 1000 ohm resistor. That's also a 1000 ohm resistor. But in any case, if I set this to about 5.6 volts approximately, we'll have about 5 volts across that 1K resistor. About 5 milliamps of current will flow. And I can go up to about 10 volts here because the red LED is going to drop a couple volts. We can get up to about 10 volts across this 1K resistor for about 10 milliamps of current. So now, here's the schematic diagram. NPN bipolar junction transistor current source, but it's an adjustable voltage across the current setting resistor, and therefore it's an adjustable current source. 1000 ohm resistor, very simple. Whatever the voltage is across it, 1 volt, you get 1 milliamp of current, 2 volts, 2 milliamps of current, and so on. Now that current comes through this path right there. Positive supply down to ground, and therefore whatever current we set through the resistor also goes through a load and then the transistor. When it comes to setting the voltage across the resistor, of course, it's wired as kind of an emitter follower in a way. So you got the voltage at the base there, which is adjustable because we got a trim pot, and so we can set the voltage there. You're going to lose about 0.6 volts, approximately, maybe 0.7 or maybe 0.5 or whatever. But in any case, that's how you set the voltage across there. It transfers with just a little bit of a drop, about 0.6 volts. So now, we're going to aim for about 5 milliamps of current going through the LED. So I'm going to set 5 volts across this current setting resistor. It's a 1K resistor, and we're not going to get too nitpicky, but whatever voltage we got there at the base, it's probably going to be approximately 0.6 volts higher. And now we want to make this so it's not connecting anything. I'm going to move that jumper because we got to complete the circuit through the meter. Going to set it to measure milliamps of current, and you don't want to accidentally measure the wrong thing while you do that. That's why I completely disconnected it. Oh yeah, I want to get that over there, and now we will get current flowing through the meter. So yeah, that should be about 1 milliamp of current for each volt we set across the resistor. Not going to line up perfectly, but pretty close it looks like. So now, again, we're measuring the voltage across the current setting resistor. It is a 1000 ohm resistor, so each volt across it we should get about 1 milliamp of current. And I'm finding that 10 milliamps of current is probably pushing this a little too much. It kind of throws things off. So I'm going to set about 9 volts across the current setting resistor. And so now I'm going to pluck this jumper, and we're going to see weird voltages. But in any case, I'm going to have this where it's not connected to anything while I change the meter to measuring current, because you don't want to accidentally measure a voltage while you are turning the meter to measure current right there. Be best not to have current go through the meter at all until you are ready to actually take the measurement, as you see there. And again, we put about 9 volts across the 1K resistor. We got about 9 milliamps of current. So a little low for the red LED, but we could use a lower value resistor so we get more current per volt. Get the meter off of measuring current as quick as possible.